In this video, I will discuss Linux socket permissions as they pertain to TCP Dump or other network sniffers. This video is designed to give you a fundamental understanding of socket permissions because as a beginner you may encounter issues where you're trying to sniff on a live interface and it's not allowing you to. This explains how and why. To get started, the way we're using socket here is we are referring to a system call. A system call is an interface that a program uses from user land to ask the operating system kernel for information or resources. The particular type of socket we're using creates a low-level packet interface from which packets can be seen from the device driver level or the layer 2. And this particular type of socket is called an AF packet socket. And we're also passing a SockRaw argument to these types of sockets. So these two attributes, the AF packet and SockRaw arguments passed to the socket system call, are what is commonly used in sniffing applications. Another thing to be aware of is that these sockets require, these types of sockets, the AF packet SockRaw sockets, require a user to be a super user to actually open the socket. So let's go ahead and move over to our demo system here. So you can see I'm running Ubuntu 14.04 and I am user ID of 1000, so I'm a normal user, unprivileged. I'm going to do my first step by launching TCP Dump. It says that there's no suitable device found. Well, we need to see if there are suitable network devices. So let's type IP link. And I see that there are 3. So let's try this again. Say, hey, I'm listening to the interface with the -I option, and then I want to use ETH0. It says you don't have permission to capture. Okay, so this is a little bit more informative. Operation not permitted. So you can see it's a socket error. So what's the difference? Well, how come the other one said no suitable device found? Well, let's figure it out. So let's use what's called a system call tracer on Linux called strace. We'll pass an argument of socket to say only print socket system calls, it's a filter, and run TCP dump. I'll go ahead and clear the screen here. Oh, there's a bunch of them. So what this did was it launched TCP dump with strace attached to it, and it before each entry of a system call and exit, it records the information from the system calls. So you can see here's the system calls and then the error messages that are returned on exit. And you can see there's a bunch of sockets created, or tried to be created. They all failed though. Operation not permitted. Nothing was successful with the 0. Mostly -1 EPERM issues. It even tried to do a Bluetooth socket here, and of course we don't have that support for that device. So essentially what it looks like is that TCP dump, when you just issue TCP dump like that, it tries to look for all the interfaces and bind to a socket for each one. And so we can try to double check that with just specifying one interface, and you can actually see it only tried twice. And you can see since it's a network or Ethernet interface, it tries to use PF packet and then SockRaw and then some buffer size. So first, let's go ahead and open up the manual page for socket, and you can see that it creates an endpoint for communication. Here's a bunch of types that we saw. And the one we're specifically looking at is AF packet. It's a low-level packet interface. And here's a reference to the man page just for that. Also, you can see as the socket has the indicated type, here are the clearly defined types. And the one that we're looking for sniffing, that's what we're concerned with, is SockRaw, which provides a raw network protocol access. So let's go ahead and try that other man page, packet 7, or man 7 packet, because that's in section 7. And you can see that packet sockets are used to receive or send raw packets at the device driver level. So this is what we need to actually take advantage of the benefits of TCP dump whenever we can actually see things like the Ethernet frame header. And that typically includes the source MAC address, the destination MAC address, and a protocol field that specify what that Ethernet frame will be carrying above it, such as IP or IPv6. And the argument that we saw, the SockRaw, is what actually allows you to get that link level header information I just talked about with in the case of Ethernet, which gives you the Ethernet header. It's the SockRaw option, passed for PF packet. So that gives you a little bit, so you can take a look at this man page if you're interested in it in further detail. So go back to my notes here. What we need to do now is show you how you can actually use the interface whenever it needs privileges it doesn't have. So we just use sudo, right? So an Ubuntu will have sudo. So I'm just going to use sudo and use TCP Dump. And what actually happened was it bound to the first interface it could find, and this one was ETH0. And I'm actually now sniffing traffic. I could also do -I to say, hey, I want to specify a specific interface. I can try ETH0 that way as well. And you can see that it is working. Another way we can do is we become root. So we can do su, and let's see what my root password is here. Now I'm root, and now I can also listen on the interface live, and of course it picks it up automatically. All right, that concludes the requirements for sockets, for creating them and using them to sniff on an interface.